So, hello everyone. As you know me, I'm Fridolin from Bayesian Analytics Core, and today I will introduce analytics or fabric8-analytics Core. I will talk about internals briefly, and I will introduce all the components we have in fabric8-analytics Core and basically how they are interconnected. So just to give some brief introduction, fabric8-analytics Core means data ingestion for analytics. It's some kind of larger engineering group inside fabric8-analytics. And you are guys familiar that we have streams. So we have fabric8-analytics Core stream that is responsible for data ingestion, and that is the thing that I will speak about. Then we have data model stream that is responsible for syncing data to various databases and manipulating with data. Then we have fabric8-analytics like analytics stream that are guys who are responsible for analytics and data science. And then we have UI stream who is responsible to showing all the results that we have to end user. Just to have some historical background, fabric8-analytics Core was previously named KUKOS, Curated Content Stream, that is the abbreviation KUKOS. Now you shouldn't find any KUKOS terms inside source code, but in case you find KUKOS or CCS, it's left over from last days. And then we moved to a project that is called Bayesian. We are still internally called Bayesian, and officially we are fabric8-analytics. As part of transition from KUKOS to fabric8-analytics, we moved completely to Amazon AWS. So we are no longer running, for example, only on Kubernetes or only on OpenShift inside Red Hat, but rather we run all our infrastructure on Amazon AWS when it comes to staging or production environment. And as you know, we are part of larger analytics pipeline, and we are computing and feeding raw data for data scientists and analytics guys. Here is I would say not strictly complete list of core components, but these are core components. And as you know, we have a worker that is fabric8-analytics worker. We have server that is a REST API server. Then there is some jobs service. I will talk about these more deeply in a few minutes. By the way, in the whole presentation, I put a link so you can, if in case of anything is not directly clean to you, you can follow these links and find details under either some repo or in documentation. So these three parts are like core components of fabric8-analytics Core, and they were developed for fabric8-analytics Core. Then we use hosted components, that is RDS, that is Relational Database Service, hosted on AWS. And we have local alternative, although you can imagine how we use it is basically same as PostgreSQL. Just a note, we run PG Bouncer on top of it. I will discuss more details later as well. Then we have AWS Simple Cloud Storage Service, that is S3. We have local alternative Minio S3, so what you can deploy on your local setup on your laptop and use it as AWS S3. We also use SQS, that is Simple Queue Service. And as an alternative, it is RabbitMQ. I will talk about it as well later. So these are like 6 core components in fabric8-analytics Core. Now, how does the whole workflow, or how does the fabric8-analytics Core work? I will not show you everything, like everything from for example, Che or everything that is triggered from OpenShift.io, but I would rather focus on fabric8-analytics Core. So let's say we have a user who wants to explore fabric8-analytics Core. Now, there are two possibilities to do that. First is jobs API, that is REST API service. It is run, it is deployed, and it is used mainly by developers, and it serves some internal use cases, and it is some kind of internal administration console for developers. Then we have API server. That is server that is directly serving requests to users. In any case, if you access jobs API or API server, in any case, there are triggered or there are posted messages to SQS or RabbitMQ, and in term of messaging. And basically, these messages keep all the information related to what should be computed and how it should be computed. And these messages are queued, so SQS is simple first in, first out queue. Once some worker is ready, and basically these green rectangles at the end are workers. If some worker is ready and can process or consume some message, it just receives message, it removes it from SQS and starts to processing it. We use internally PG Bouncer and RDS, and basically what we do, we store results that are computed by workers in RDS. This ensures that we have consistency in workers and in everything that is computed by workers. So once a worker finishes some computation, everything that is computed and is related to that particular message is stored in RDS or Postgres. At the end, we sync data to S3, so these data are available to analytics guys and data scientists. Then we have also other parts. They are not strictly core components, but we have also data importer that handles syncing data to the graph database once we have everything done in the core. And just to make the whole picture more clean, here are all data dependencies between components. So data importer uses S3 to sync data to graph database and is run by workers. Jobs API service uses RDS, but I will talk about it later. There is also another component that is not strictly core component, and it's a project that was developed for Fedora, and that is Anitia. It's used for upstream monitoring, and workers use it to fetch some data related to upstream releases. So this picture should state all the components and how they are interconnected in fabric8-analytics core. Okay, so now let's focus on fabric8-analytics worker. Basically, fabric8-analytics worker receives messages from a message broker. As you know, it could be SQS or RabbitMQ, and it can also produce messages to message broker. Basically, anyone who is subscribed to message broker can publish or receive messages from queue. Based on a message and message type, worker runs some particular task. As you know, these tasks produce data, and these data are stored in storages or databases as configured. The whole configuration is done in YAML configuration files, and these YAML configuration files have two main abstractions. One is task, that is some kind of execution unit that is encapsulating some particular logic. If you want to imagine something behind it, it could be GitHub statistics, or computing CVEs, or computing digests, or gathering things like upstream releases and stuff like that. These tasks are grouped to flows, and basically these flows are a group of tasks that respect some data or time dependencies. Flows are not strictly tasks or only tasks, but you can also have flows of flows in your configuration file. I will state it later. Basically, the whole YAML configuration is done by Selenium, and it was developed for back in Kuko's days, and now it is used in fabric8-analytics worker. You can click on Selenium to go to the project or find some configuration options that you can write directly to the YAML configuration files. Important thing to state is that fabric8-analytics workers run Celery. That is quite popular and quite famous open source project that is used for serving distributed tasks, and you can find it in many projects like Django and many others, and it is quite widely used by community, and it is one of the most famous projects in Python world. On top of Celery, there is Selenium. By the way, Selenium means celery in Greek, and Selenium allows you to model some advanced task flows because Celery has some primitives, but they were not that suitable for fabric8-analytics core. We have also different types of workers. You can find API workers that serve only requests that come from API server. Then we have also ingestion workers that serve ingestion in the background. The main thing or the main idea behind this split is that we wanted to maintain or provide API to provide SLA for API requests, so we can independently scale API workers and ingestion workers. There are also possibilities to do like per task specific workers, so you can deploy one worker that serves only some specific tasks. So for example, you can deploy your own worker that does GitHub statistics gathering, or it computes CVEs and stuff like that. Just one note, and quite important note here, is that the terminology like what is worker and what is task is quite misleading even in the team. So just to make it more clear, worker is something you deploy, and task is the logic that is run. So task means gathering GitHub statistics, gathering CVEs, computing digests, and these tasks are inside worker that is deployed and run in the cluster. Okay, so now if you want to get familiar on implementation level, I will guide you basically how you implement your own task in the core, and this should help you understand how the whole core works. So here is like four or five lines of Python code that basically import base task, and this base task handles some high-level abstraction, and it also handles, for example, audit, that is edit and stuff like that. You don't need to be that familiar on implementation level with base task. Just if you want to write your own task, just derive from this base task and implement the execute method. In this particular scenario, we have my task, that is the task that we want to implement. So it derives from base task, and it implements one method that is execute, and this method has arguments that are dictionary, and we have all the arguments that are passed to flow in this dictionary. Then you do all your logic there, and after that you basically return dictionary. There is some kind of basically all tasks in the core return dictionary, so we can serialize them quite easily, or do advanced checks or checks against schema. So if you implement your own task, just return dictionary to be consistent with other workers. Once you are done, you just register your task in the init file in workers directory inside fabric8-analytics worker, and it basically exposes your implementation. It is not necessary, but it is nice to have it in one place and encapsulate or hide implementation logic behind it. By this, you are exposing my task, that is class, to package fabric8-analytics workers. So once you are done in registering your task here, you should register it also in the YAML configuration file, and this YAML configuration file basically states how these tasks are configured. So in this particular case, in case of my task implementation, we register this task, we give it a name, it is my task or lowercase. Then we point to the implementation, so we point to the import, from where this task should be imported. If you remember, that is the same import as we registered our task in the init file. Then we have class name, that is name of the class, obviously. Then there are other configuration options. For example, max retry in this particular case gives you power to express how many times you give retries to a task in case of failures. So if a task fails, it is marked as failed by default. But if you want to retry, like you want to try it once more times or 3 times, you can do that by stating it in your configuration file. Then there is retry delay or retry countdown, that is number of seconds before the retry is done. This is very nice to have in case of querying for or contacting some external resources, and if some resource is down or is under heavy load, you just wait some time, and after that you retry, and hopefully you will succeed. Or if a task fails, it is marked as failed, and we can easily reschedule it in future, so don't worry about it. Then you assign storage. This storage is used for storing results of tasks. This is called based on Postgres, and it is the main storage adapter that we use. You can find configuration of this adapter as well in the nodes YAML configuration file. Then we have configuration of queues. Basically, this configuration or queue configuration directly inside the YAML configuration file allows us to distinguish a worker administration region, that is a region for serving requests. So if you do remember, previously we have API workers that serve only API requests, and then we have ingestion workers that serve or compute only tasks that are used for ingestion. So worker administration region environment variable is used for that purposes. Then there is deployment prefix. Deployment prefix just prefixes different deployments, so you can have your own instance running on AWS, and it doesn't interfere any other deployment or production or staging deployment, so you can easily configure your deployment by these environment variables. We do it automatically, but if you do want to do some magic behind or explore magic behind this, you can do that. Then every task has its own queue, and these queues are versioned. This allows us to easily deploy different versions, and they don't interfere. Everything that is put into the square brackets, it means that it's taken from environment variables. So these environment variables like deployment prefix, worker administration region have to be present in the container once we do deployment. We have also some abilities to run only some particular tasks. So we have something that is called selective run function, and this selective run function ensures that there are reused results from previous runs in case of you have some data dependencies between tasks. I will talk about it later. And Once you register your task, you just put it into the flow definition configuration, and in this case, we put it into Bayesian analysis flow, that is our core ecosystem package version specific flow. And we stated it, as you can see, there is edge configuration or edges where you state all edges of your graph. I will show that graph later. So we stated my task that should be run in Bayesian analysis flow, and it doesn't have any prerequisite in case of other tasks that should be run before this task. So just to summarize it, here is a complete summary on how to add a new task to existing flow configuration. You can find documentation, so you can find Celery documentation in case you are interested in some low-level things. If you are more interested in how to do it with Bayesian or fabric8-analytics worker, feel free to reach to Selinon and Selinon lib documentation. I'm maintaining it, and hopefully there is everything stated. If not, feel free to reach out to me. And if you have any questions regarding how does some things work, feel free to reach out to me. There is Git project on GitHub, that is Selinon, and basically the whole development of Selinon or dispatcher, as it is called internally, is done there, and we I publish releases on PyPy, and after that we use it in fabric8-analytics worker. Just to point out, we don't use versions from PyPy because development of Selinon was quite active, and we didn't want to every time do releases. So we use update selinon.sh script that basically has the version that we are using inside. And feel free to run this update selinon.sh script, and it will install Selinon to your local system. And of course, don't forget to hit start button on GitHub. As of today, when I checked how many stars, we have already 45 stars. Most of people who by most of the people who are not in our team. So feel free to hit start button and make this project even more famous. Okay, so that would be our worker, and I would like to proceed to also other components that we have in the core, and to make you more familiar with them. So we have fabric8-analytics jobs. Basically, this is the internal console or management console that is used by developers, and it is running Connexion on top of Flask using UWSGI. It is configurable by YAML configuration file where you state your endpoints and points to appropriate endpoint configuration. Feel free to reach out to Connexion documentation. It's quite nice and straightforward. By using Connexion, it also allows us to support OpenAPI transparently, so anyone can browse using Swagger UI the API and check what is available, what are responses, what is data that are needed for some particular endpoint, and what are results. It's very nice. The way how fabric8-analytics jobs is implemented, it uses handlers, and these handlers are job specific. These handlers could be either periodic jobs or one-time shot jobs. And if you notice that we analyze, for example, 10,000 Python packages available in PyPy, this is done by a handler that is executed in the job service and publishes messages to the SQS, and workers consume these messages and analyze these Python packages. But the logic on how or what Python packages should be analyzed is done in handlers. We have also support for npm or Maven, and soon we will support more ecosystems. So we will introduce new handlers to fabric8-analytics jobs service. Just to point out, if you want to use fabric8-analytics job service in production or staging, you have to use GitHub authentication. It is documented in the README file of fabric8-analytics job service, so feel free to reach out to that. And this is some kind of prevention, so not everyone can schedule new batches of analysis and so on. So GitHub token is used for authentication. To authenticate yourself, you have to be a member of fabric8-analytics organization on GitHub. Then there is another component that is called fabric8-analytics server, that is API server, serving a REST API. It is simple Flask application running on top of mod WSGI. It does not provide OpenAPI, but there was already discussion that we should introduce OpenAPI to fabric8-analytics server as well, to easily expose what data and what endpoints we have available there. It's basically fabric8-analytics server serves all data to OpenShift.io users. It serves data for chat plugin, for recommendations, also for OpenShift.io UI, and it requires JWT token. If you want to communicate with fabric8-analytics server in production, you need this JWT token. It is periodically generated, and these tokens have limited time, so you need to periodically update them. As of today, we have two main use cases for fabric8-analytics server. The one is component level analysis and stack level analysis. In the future, we would like to introduce new endpoints and new stuff on fabric8-analytics server. Then we use AWS Relational Database Service, that is Postgres hosted on AWS. It is used for various purposes. The main are basically bookkeeping data in our flows. So when you saw Bayesian Postgres, it is basically this RDS instance, and we guarantee consistency. So if there are issued many analyses for the same package that could occur, we guarantee that there is consistency when it comes to data or time dependencies. RDS is also used by Celery to keep some internal state of tasks, like if a task was scheduled or if a task already finished, and these information are used by Selenium to schedule other tasks as well, based on your YAML configuration file. It is also used by job service. Basically, we handle all tasks that need persistency. So for example, if you have periodic jobs, these are not removed after you redeploy job service, but rather they are stored in Postgres, and they are transparently used as if job service would run like forever. The RDS is running behind PG Bouncer. There was quite large discussion regarding this back in Kukos days, and why PG Bouncer is used. It is used because of recycling connections. Because in case of Postgres, you need at least 20 megabytes of memory just to keep information about state. So PG Bouncer recycles connections and acts like some kind of connection pooler, and it allows us to scale to far larger numbers. So for example, as of now we have 60 workers in productions, and you can imagine that 60 multiplied by 20 is quite large number, and it would only be needed to keep that large number of connections, and it basically wouldn't do anything else. Then we have AWS Simple Queue Service, that is SQS. It's asynchronous messaging. We use FIFO queues, but you can also configure SQS to serve like in LIFO queues. That means last in, first out, but we really don't want to do that. And SQS is quite straightforward. You have producers who publish messages and consumers who retrieve messages. There can be connected multiple producers and multiple consumers, and you can use SQS to scale quite nicely. All messages that are served to or that are sent to SQS are JSONs. These JSONs carry additional information. They carry information that are related to task flow metadata. They also carry, these metadata are used by Selinon. They also carry information related to Celery, and we also publish ecosystem package version triplets in the main flow or in general flow arguments that are passed to flows by a job service or API server. One important note to state there, messages are limited. They can be only 256 kilobytes in total. So in general, it is not a good idea to publish anything I have an echo. So hopefully now. Suddenly my mic was turned on. So you don't want to publish messages that could be large. We have also things like one queue per task type, so we can transparently do versioning, as I stated, but it also allows us to do throttling or task prioritization just out of the box, basically. These queues are configurable via YAML configuration files. I showed them to you. Then I think the last core component is AWS Simple Cloud Storage Service, or S3 in an abbreviated form. It's simple flat object storage, and we store raw JSON files there. These raw JSON files are used for fabric8-analytics analytics guys or data scientists, and we generally use prefixes in buckets, so you can find different buckets when you do deployment to staging or deployment to production, or your local deployment and you want to communicate with AWS S3 rather than local alternative that is Mini or S3. We store various data, for example, README files and results of analysis. You can browse it quite easily from AWS Web Console and explore data that are there. Also, AWS S3 are configurable from Nodes YAML configuration files. We state things like if buckets should be versioned or if they should be encrypted, and stuff like that. Basically, for each bucket, we have one adapter that encapsulates all relevant logic there. I think configuration is pretty straightforward in the Nodes YAML configuration file. And in case if it is not clear, you can still reach to Selinon configuration documentation, or you can reach out to me as well, or anyone from core stream, and we will guide you in case you want to do contribution to core stuff. And one important thing to note, We have fabric8-analytics common repository that keeps all the common resources for all repositories, and you can easily set up your developer environment just by doing git clone and running the setup.sh script. After that, you will have basically the whole core ready to use. To build the whole system, you can issue docker compose.sh build, and to bring the whole system up, you can run docker compose.sh up. Don't use docker compose directly, or you can use it, but docker compose.sh script ensures that there are bound also volumes to your deployment. So if you do make some changes in the core, you don't need to rebuild your images and wait quite a long time just to build images, and after they are done, after that you can test it. So once you do docker compose.sh, you can be sure that all changes are bound to the container itself. And as you know, we are running Docker Compose. The intention is to switch to pure OpenShift development as it is closer to production. We want to switch to pure OpenShift development in case of local development setup, as well as for testing, that is CI, that runs Docker Compose now as well. So that should be the core, like core. And if you bring the system up using Docker Compose, you will have also a graph database and data importer available there. They are not strictly like fabric8-analytics core components, but they are available there because of dependencies between components. And they are maintained by guys in a data model stream. And the main idea behind these two components is to help to move data suitable for advanced analytics and data science analytics guys and data scientist guys to run their algorithms. In case of graph database is like stack of three main parts. That is Gremlin HTTP. Gremlin is a querying language. There's Titan, and also Titan that does heavy load and maintains graph, and DynamoDB, that is AWS hosted key value store. Another component that is not strictly fabric8-analytics core component is Anitia. Anitia is used for upstream monitoring, as I've already stated, and it's an external project. It was developed for Fedora. External means like not in our team, but I believe it was developed by Red Hatters, but I'm not 100% sure. We use it because it is very nice. It is a REST API server, and it exposes us things like when some particular project made some new release. You can browse it on GitHub, the whole development. To summarize it, we have some code, guidelines, developing, deploying, and how we all do this. We write most of the code in Python 3. We try and we do our best to be PEP 8 compliant. PEP 8 is a standard that basically states how Python should look like, and stuff like how the indentation should be configured, or you should use, for example, 4 spaces rather than tabs, or how to write documentation strings for functions and stuff like that, and many other things. But even if we write code in Python 3, we still have some code that is not written purely in Python. That is, for example, Mercator, which is written in Go language, and it has Go or language-specific handlers. So you can find, for example, Java handler, that is a handler that handles Java, Java dependencies, or C# handler, and Python handler and stuff like that. So you can find quite large variety of languages directly in Mercator. All containers run on CentOS, at least those who are deployed in production or staging. And we use many community tools that are written and available out there, and they are written in many languages as well. We try to utilize these external tools, not to reinvent wheel for many cases. So we, for example, use scan code that is written, by the way, in Java, if I remember correctly, but I'm not sure. And we use it for analyzing or finding licenses inside artifacts. We do automatic CI/CD deployment. We have configured pipelines. Most of the work and most of the stuff is handled by service delivery team. They have own repository where you state how you want to deploy and what components you do have. And we have fully containerized solutions, so we run OpenShift in production. So this is screenshot I made today, and as you can see, this is our production. There are pods running, and you can find it. So what's next? I try to summarize some quite interesting documentation or other resources that could be useful for you. But don't hesitate to contact anyone from core stream, and we will help you either with setup or with development in case you are interested in the core part of fabric8-analytics. So that should be from me, and if there are any questions, feel free to ask. And I see some questions in the chat, so I will go through them. So I'm not sure which YAML configuration file. We can open discussion. JSphere, you ask if where the YAML configuration file is located.
Yes, so I asked this question to know where the tasks are configured. You were going through, right? Configure tasks. I was asking about that YAML file. But Sam and Nitesh already gave me a reply in the chat.
I see. Yes. Basically, I published this presentation, and you can find links to these. And I can see that Sam and Mitesh as well pointed you to right files. Just note, we recently renamed KuCos lib to fabric8-analytics worker because we are no longer KuCos. So you can find it in fabric8-analytics worker directory inside worker. Yes, okay. And I see now some responded to. Yeah.
Yeah. Thanks.
Now I see a question from Samuzal. In a multiple worker deployment, how can we map a set of particular tasks to run on a specific worker? So to answer that, if you remember, there was the YAML configuration of fabric8-analytics worker, and how we do that. We maintain, I think now we have 4 types of workers, and basically we share all the code, we reuse all the code, and we deploy monolithic worker. That is, every worker has all the logic inside it, and we parameterize like what administration region should be taken care by environment variables, And there are also environment variables where you can state on which queues should a worker listen on. So there is something that is called worker exclude queues and worker include queues. And these environment variables, if set, either exclude some queues from listening or include some queues. So if in case you want to run one worker that runs only this task, my task, you just change deployment configuration and you change worker include queues environment variable and you state my task version 2 and everything is transparent and this worker serves only these particular tasks. Is that clear?
So Frido, by deployment configuration you meant OpenShift template YAML?
Yes.
Okay.
Okay, Frido, understood.
Any other questions? So in case of no, I would like to thank you for your attention. And in case you have any other questions, like in future, feel free to reach out to anyone in the core stream, and feel free to ask, and it can save a lot.
Hey, thanks a lot, Frido. This was really nice presentation.
Thank you. Thank you, guys.
Indeed, Frido. This is a very good insight.
Mm-hmm.
Thanks a lot for taking this up.
Okay. Yeah. Thank you, guys.
Thanks, Frido. It was nice. Thank you very much.
Thank you.